Welcome to the recording of CSC103, Object-Oriented Programming. In this course, we're going to start talking about what object-oriented programming is and why it's important to understand. So throughout this discussion, we're going to look at a number of different things, but the biggest piece is going to be looking at how we can define a class. By creating a class, it allows us to define a custom data type. And we've seen data types in the past. These are things like integers and strings and bools. But with classes, we can define our own that are unique to our problem domain. We'll then look at how we can build fields to maintain state in our classes. And then we'll, at the end, talk about enumerations, which are a way of defining a group of constants. So we're going to get started with our first objective, which is to understand the world from the perspective of object-oriented programming. And to do that, we're going to start by defining object-oriented programming, looking at how we can create classes in C#, and also how we can define fields inside of our classes. So our goal as a programmer is to write software that is easy to understand and maintain by yourself or other programmers. And doing that takes some planning and some time. It's difficult to just sit down, start writing code that is easy to maintain and easy to understand. You want to plan it, and you want to make sure everything is set up correctly. So this is important for a number of things. First, if you organize and structure your code in a correct way, it's faster to fix and find bugs, and it's also faster to add new features. Now, this is a very difficult concept to understand as a new programmer because it's difficult to see what it's like building software. Right now, if I told you when you are starting to build software, it can be difficult to add and implement new features if you don't structure your code correctly. That may seem kind of distant and not really make sense to you. But rest assured, I can tell you that structuring your code in a correct fashion and using design patterns from object-oriented programming really can make it easier to add new features in the future and also find bugs. You know, for example, when people write code that's not structured and is tightly coupled and things like that, it's very easy to fix one bug, but then introduce new bugs by changing that code because everything is so tightly coupled and not designed correctly. So we're going to start understanding what it means to use object-oriented programming and to write software using certain design patterns. So what exactly is object-oriented programming? So pretty simply put, object-oriented programming is a design philosophy that was created so that we can handle building complex programs. And it's structured around this idea of creating objects that represent things in the real world because that makes sense to us as human beings. So for example, if we were building an application dealing with music, it would make sense if the objects that we were interacting with were also in respect to music. So things like albums, songs, and playlists. These are things that we understand as humans that relate to music. Same thing if I was building maybe a running application or a Nike application. You would see things like runner, workout, route. And same thing with a drawing application. You would see things like circle, square, eraser. This is the core idea of object-oriented programming. We want to build objects that relate to things in our problem domain. So when it comes to object-oriented programming and building types that do model the real world and model our problem domain, we want to look at how we can actually define a new type. Now, as I said before, as a reminder, we've looked at built-in data types. We've seen things like string, int, double. We've worked with these things, but they're not unique to our problem domain. So what we want to do is we want to start building types that mimic and represent our problem domain because it makes sense to us as humans. So We can define new data types by creating a class. Simply put, a class is a blueprint. It represents something in the real world. It models something in the real world. So, for example, in this diagram, on the left-hand side, we have a model of an airplane. So that would be similar to the actual class definition. It defines what the airplane looks like on paper, sort of. And then on the right-hand side, we actually have a real airplane. This is a physical airplane, or an instance of that model. And we'll look at both of these situations. But a class basically represents the left picture, the blueprint or the model of the object. So when it comes to creating a class, there are two major components inside of them. We have the data component and the behavior component. So the data represents what that class has, and these are implemented through what we call fields. So to give you an example, imagine we had a class called car, and some of the fields or data that you would see are things like number of seats, color, make, model, year. It's basically information about the class that we can store. Now, on the other hand, we have behavior. These are the actions or the things that the class can do. So we implement those actions through methods. And for example, in that car, we would have things like lock the door, turn on radio, drive, maybe reverse. These are the actions, the things that the class can do. So, like I said, a field is really a way that we can store data inside of a class. You can think of a field as a variable that's owned by the class. So, for example, let's say we had a class called dog. Some fields that you would maybe see on a dog are things like name, age, weight, and breed. Right? These are all things that describe and their information about a dog. Let's say we had a class for a button. Maybe some fields that you would see are things like width, height, position, and text. And the same idea applies for methods, right? Methods are just code blocks that contain C# statements that provide logic to perform work related to the class. So these are your actions for your class. So for example, if we had a dog again, these are things like bark, eat, walk, lick, sniff. Notice that these are actions, things that the dog can do. And the same idea for a button, we would have things like show, hide, click, and resize. Actions for a button. Alright, so let's do a flash quiz now. Now remember, with flash quizzes, I'm going to leave the question up for like a second. If you want to think about it on your own, you can just pause the video and look at the question, and then I'll go over it. So question number 1, a class is a type that combines both data and behavior. Is that true or false? And the answer to this is true. Remember, yes, classes have fields and methods, or data and behavior. Number 2, a field defines behavior associated with the class. Is that true or false? And the answer here is false, right? A field is with the data, not the behavior. And question number 3, you can only have one method in a class. Is that true or false? And the answer here is false. Although we didn't really talk about that specifically, I showed examples of multiple methods for a class. That would be the way that you would have figured that out. Alright, so one of the challenges of object-oriented programming is being able to identify classes that you would create for your problem domain. So for example, imagine we had some type of GPS application, and we were starting to design this in a program. What types of classes would we maybe be creating? And if we think about this, let's go through some. Maybe there'll be a class to represent the map. Maybe there'll be a class to represent our current position, or a position in general. A class to represent a route. to represent the details of a street, a turn. These are all possible things that we may be working with in our problem domain, and those things can translate into objects or classes. So let's practice with this a little bit more. Let's do another flash quiz. So question number 1, think about or name some possible classes that you may be defining and creating for a chatting application, maybe like an instant messaging application. So some things that you may be thinking of are a class to represent the message, a class to represent a user, a conversation, the connection, the history. These are all potential classes. And you may be saying, okay, well, with message, how come message is a class? Why is it not just a string? Because a message could just be a string. And you need to think about, well, what information is normally associated with a message, right? You have the message's text itself. Then you have the message's sent date and time. You have the message's status, whether it was delivered or not. So there's a lot of information, and whenever you realize that something has a lot of information around it, a class normally is a good thing to represent it. Let's try this again, a little bit different. Name a few pieces of data or fields that you may find in a chat message. All right, so now inside that message class, what are some of the fields that you may see, as I talked about? So some of you see are the date and time it was sent, the actual text, who you're sending it to, who it's coming from, the color. You can imagine a lot of different things here. And then question number 3, name some methods or behavior that we may need in a chat message or maybe a chatting application. So those would be things like sending the message, taking a picture, delete, replying, adding a person, adding an attachment, right? These are all actions that you may find in this instant messaging application. So in this first section, we started defining what object-oriented programming was and what a class is. And then we finally looked at what are the members of a class. We looked at methods and fields to describe the behavior and data of a class. Now we're going to start looking at how we can actually create a class. We'll talk about the syntax. We'll talk about how we can instantiate an instance of a class, because remember, a class is nothing more than a blueprint. And then we'll also look at how we can use the fields to store data inside of a class. So one of the first difficult things to understand about object-oriented programming is the differences between a class and an object. So remember I said a class is a blueprint. It sort of defines what the object looks like, but it's not an actual object. It doesn't have data associated with it. It defines the structure. So for example, if I was going to relate this to a house blueprint, when you're building a house, you have a blueprint, and the blueprint describes the structure of the house. How many bedrooms, how many bathrooms, where the doorways are, etc. What it does not define is the interior of it. It doesn't define what colors the walls are going to be. It doesn't define where the couch is going to be. It doesn't define what type of table you're going to put inside of it. Those are all information and things that we add to the structure of any house. So the house blueprint could really be used. You can take a house blueprint, build a house, take it again, build another house, and those houses would be identical in structure, but they look different. There'll be different colors, different amount of cars in the driveway. There'll be different things about it, but the structure will be the same. It's the same idea in programming. A blueprint defines the structure of the house or an animal or whatever it is, and then when you create actual instances, like for example when you build the house in real life, then different characteristics start to show, different colors. So as you can see in this example with dogs, we have a blueprint for a dog, but then we have the actual instances of the dog, and notice how they are all different hair color, different shapes, sizes. Everything's different, but they're all dogs because they derive sort of from this dog blueprint. All right, so how do we create a class? So A class is created using the C# class keyword followed by the name of the class. Then you'll create curly braces or a block, and anything that goes inside of that block is considered to be a part of the class. So inside that block, we would put our fields and methods that we've talked about so far. Now, naming conventions are very popular in programming, and it's common when you create a class to have the class stored in a separate file that has the same name as the class with .cs added to the end of it. Now, another concept that we really haven't discussed yet was the idea of a namespace. And we haven't discussed it because we really weren't creating classes yet, so it wasn't necessary. But now that we're creating classes, we need to have a basic understanding of what a namespace is. So I want to start off by saying, think of a namespace as a folder or an organizational tool. It allows us to define classes and then put them into a folder. And the point of doing that is to prevent naming collisions. For example, you can think of a situation where you may have two classes that need to be called the same thing because they are basically the same thing, but maybe they're in different departments or maybe they're in different domains, but they're called the same thing. If you didn't have namespaces, you couldn't do that because then we couldn't differentiate between which class you are talking about. But if you need to create two classes with the same name, if you put them into different namespaces, then you can still find the one that you're talking about by just accessing the namespace first and then accessing the class in that namespace. So basically think of it as if it was a folder. Now, object-oriented programming defines guidelines on how you should design and build classes. And one of the guidelines that many people understand and accept is the fact that a class should do one thing and do one thing well. You shouldn't build classes that handle everything for your entire program. So you shouldn't have a program with just one class managing everything. Because if you do design your program like that, it will be hard to maintain and debug and fix in the future. So, for example, when we built this class on the left-hand side called customer, it should only have information about the customer in it. When we have a class called order, it should only have information about an order in it. And maybe if you want a relationship between customer and order, you would create another class whose job is to relate them, like an invoice. So in the invoice, you can see there's customer and order information together. So you should have classes that do one thing and one thing well, not multiple things. All right, so what I want to do now is I want to jump into our first group exercise, which we're going to just simply create a class. We're not going to put anything into it. We're going to create a class and wrap it in a namespace. That's it. So let's head over to Visual Studio and let's create a new project. All right, so here we are in Visual Studio. Let's go ahead and go to File, New, Project. Once again, we're going to be creating a console application. So find consoleapplication.net and then give it a name. So we can call this Travel. Hit Enter and it creates the project. Now what we want to do is we want to create our first class, and there are multiple ways of creating a class. There are templates that will create a class for you, and then there's also just blank code files. And a blank code file can be used to create anything that you want, but we're going to use a blank code file just to get practice of creating the class manually, but I'll show you both techniques. So if we right click on our project and go to Add, New Item, it's going to show us all the possible items that we can add, and you can scroll through the list. You can see all the different things, but if you scroll down, we want just a plain code file, and you can search this as well. So I want a plain code file, and I'll call this road trip. Hit Enter. So notice a plain code file has nothing in it at all. So what we want to do is we want to build a namespace and a class. So remember, the namespace is a folder. So we say namespace, We'll call it the travel namespace. Then we add a block. Now inside this folder we want to create a class. So we say class. The class will be called road trip, and we make a block. And just like that, we now have a class defined. And we could start adding methods and fields to this, which we will do in the next exercise. But on a side note, I just want to show you that there is a built-in template as well. I can right-click on my project. I can go to Add New Item, and I can click a class. So I'll call this class Test just to show you. And notice when I do that, it automatically creates a namespace that's the same name as your project, and it creates the class for you. It also has these using statements, which we haven't discussed just quite yet, but we aren't using any of them. That's why they're dimmed out. So hypothetically, we don't even need any of them right now. So you could do it like this, or you could do it manually like this. Most people prefer to do it like this, but we're just doing it manually to get some practice. So let me go ahead and delete this. And let's head over back to the slides and continue on learning how we can start creating fields inside of our class. Alright, so remember I said a field is nothing more than a variable that's owned by the class. So we know how to create variables already. It's simply the data type, then the name of it, and then optionally some value. So as you can see, all we do is inside the class, we just define variables. We have account number, balance, and interest rate. Now those are considered to be fields. But it gets a little bit more challenging than that, because in programming we have a concept of visibility. Visibility defines who is able to see and access a specific member. So we have two basic ones that we'll discuss so far, public and private. If you mark something as public, it means anyone can access it. It's open to the public, everyone can see and access it. Whereas if you mark something private, inside of a class, then only the class itself can see it. People that are outside of that class cannot see it. And I'll show you an example of that in a little bit. But like I said, we have these things are called access modifiers, and we have public, anyone can see it, private, only the class itself can see it. And that is the actual default behavior. Now this leads to a very interesting conversation that we can spend a little bit of time talking about, because it comes down to, should I be using public or private? When do I use public versus private? These are the questions that really are difficult to answer for a new programmer. Now, I'm not going to really be able to fully answer this question just quite yet, because we don't have enough knowledge of programming, but there are some questions that you can ask yourself to figure out if it should be public or private. So if you ask yourself, does this field or method ever have to be accessed by some external source? Or is it simply used inside of the class only? If it's only used inside of the class, you should always mark it as private. If it's ever going to be accessed from an external source, you would mark it as public. Now, even this rule is not completely true, as you'll see as you become a more experienced developer. The reason why we use these is because we want to protect the state of our class. And if we just make everything public, it gives people access to data that our class is using internally to maintain state, and they could potentially corrupt it and mess up our class. So there are times that we make things private because other sources don't need to see it, and if they did see it and they modified it, they could potentially break our program. So we don't expose everything normally, but you'll learn more and more about this as you gain experience. So knowing how to actually use public and private now, this is really what our class would look like. Most likely our account number would be private because other sources don't need to have access to that. And things like our balance and interest rate, that could be public because maybe other classes are interested in knowing the balance and interest rate of a bank account. because they could do things based off of those values, whereas the account number is probably something that they don't need. Notice now, remember I talked about Pascal and camel casing in a prior course? As you can see, I told you that those casings can actually give information about a variable. And you can see here, the private member is marked or is using camel casing, and the public members are using Pascal casing. And that's what I meant. If you see a field and you see, if you're using it in code and you see that it's using camel casing, then you know it's private from just, you just know it because of the casing, and you don't have to scroll up to the definition to figure out that it was private. Whereas if you see something in Pascal casing, you're like, oh, this is public. So then you know without having to scroll up and look at the definition. So we have a basic idea of how to create a class, which remember, once again, is the blueprint. But when it comes to actually creating instances or objects, it's a little bit different. So if you look at this code here, you can see that we are creating two bank accounts. We have a savings account and a checkings account. So the syntax for creating an instance of a class is using the new keyword. So you start off with defining a variable. So in this case, we say bank account savings. This is the same thing as saying int x, right? We're just defining a variable. The only thing different is that the value that we assign to it is not a value like a number. It's an object. So we say new bank account. That's allocating memory and giving us space to store all this data. So what this means is now savings will have an account number, balance, and interest rate, and checkings will also have a separate account number, balance, and interest rate. They have their own separate memory. So once again, just to re-emphasize this, a class definition is a blueprint. You can take that blueprint and make multiple instances. So we had one bank account class, but now we actually have two actual bank accounts. Now, our class has fields that we defined in it. For example, we had those balance fields. So the way that we access the fields of an object is we use the dot operator. So notice how our bank accounts are called savings and checkings. So if I want to access the balance, I say savings.balance equals, or savings.balance to retrieve the value, or checking.balance. We access it as if it's a regular variable. We just use the dot operator to access it. So you can see right here, we're assigning the value, and then right here, we're retrieving the value. So we have read and write access to this field. All right, time for another flash quiz. So question number 1, an object defines an instance of a class. Is that true or false? And the answer here is true. Yes, an instance and an object are basically the same exact thing. Number 2, to make a field accessible, you must add the blank keyword. All right, that would be C, public. Yes, if we make something public, then it's accessible by classes or other things outside of that class. And number 3, select the missing code to complete the following program. So the correct syntax for calculating net worth is A, it's savings.balance plus checkings.balance semicolon. The other ones have mistakes in them, so B is actually C++, C, there's no semicolon, and D, we're using the AND operator, which we wouldn't do that in this case. Alright, so now let's go ahead and jump back to our exercise for our road trip, and let's continue building our class. Alright, so here we are back in our group exercise. And remember, we left off creating our road trip class. So what we're going to do now is we're going to start by defining some fields for our road trip. So we're going to start off with saying public double miles, public double hours elapsed, and public double gallons used. So now every time we create an instance of road trip, there'll be 3 variables that we can use to store data. And remember, these fields are in respect to the road trip. They all make sense. So let's switch back over to program.cs. And inside of main, we have to now actually create the instances. Remember, road trip is just a blueprint until we actually give it some memory. So we're going to say road trip, and we'll call this one chores equals new road trip. So we created a road trip object, and we'll create another road trip object called vacation as well. So we have 2 road trip objects, and our goal for this exercise is just to dump some data into the variable and then print the data to the console. So let's go ahead and say chores.miles was 50. Chores.hours elapsed was 2. Chores.gallons used was 1.5. Then for our vacation miles that we did was 400. Our vacation's hours elapsed was 12. And our vacation's gallons used was 9. So we set some data in our fields. So our chores has some data, our vacation has some data, and now we're just going to print it to the console for some practice. So let's print them all. So we'll say console.writeLine, let's print chores.miles. Console.writeLine, we'll say chores.hours elapsed. Console.writeLine, chores.gallons used. Console.writeLine, vacation.miles. Console.writeLine, vacation.hours elapsed. And console.writeLine, vacation.gallons used. So we just printed out all of our values. If I go ahead and run this, you'll see that the data was actually stored and captured, and then we printed it to the screen. So here's the output, 50 to 1.5, 400, 12, 9. So everything seems to be working. If you want to separate them, you can, add some stuff. So you could say chores, maybe something like that. And you could say vacation, just so that you can see the differences. Looks kind of messy, actually. Let's add a new line there, maybe. Looks a little bit better. All right, so that's the output. Let's jump back to the slides and continue on. All right, so in this last section, we started looking at how we can define fields within our class and also how we can instantiate an object. Now we're going to move forward a little bit and we're going to start talking about enumerations. And an enumeration is basically a group of constants, and we learned what constants were in the first C# class. So we're going to look at defining how to create an enumeration type, because an enumeration is a special data type, sort of like a class. And then we'll look at how we can use enumerations and why they're beneficial. So like I said before, an enumeration is simply a group of constants. So as you can see here, we're defining an enumeration. You can see we're using the enum keyword, and then we give it a name. So this enumeration is called months. And if you look inside of the enumeration, you can see we have all of the months separated by commas. So this is a little bit interesting. Now, one thing you need to understand is that with an enum, it defines a group of integral constants. So they're all integral based, so like numbers. So behind the scenes, there's actually something special going on. Behind the scenes, each month here is assigned an integral value. So you can see January is defined as 0, February is defined as 1, and it goes all the way to December, which is defined at 11. If you want to, you are able to assign these enumerations other values. And the formula basically says whatever the value of the previous one is, just go up by 1. So if I gave January the number 1, then February is now 2, and December will end on 12. It just takes the prior value and adds 1. So now this sort of starts leading into the question, why would I ever want to use an enumeration? What is the point of them? So for example, look at this code here, and I know you don't really understand what a method is just quite yet, but basically this shows you that enumerations are validated by the compiler. This method or action is requiring a month, and because we use an enumeration for month, it forces the caller of this method to actually use a month, and they can't pass in a potentially invalid value. So there's some validation here, although I know this is a little bit confusing. So to help make this more clear, I want to jump back to our exercise and just show you an example of using an enumeration and why you would maybe actually want one. So here we are back in Visual Studio in our road trip class. And imagine a situation where we wanted to record what type of transportation was used during this road trip. So we could ask ourselves, how would we do that? What is the process like? So for example, if I was going to do that, I could think of a few ways. I could maybe say public string transportation type, something like that. Right? And if I do this, someone could now assign a string. Back in program, they could go vacation.transportation type equals car. Right? I could do that. The problem with this technique is, well, what if some user goes like this? Well, what transportation type is that? We're not really verifying it, so now we're storing that transportation type off into this string. So if we have code that depends on this transportation type, it could get confused and we'd have to add additional logic to protect against that. Another problem is I could do the same thing. I could say, okay, so I'll do this actually. Instead of making transportation type a string, we could make it an integer. And we could say things like, okay, we know 1 is a car, 2 is a plane, and 3 is a train, right? We can say we know this, so when the user is using it, they can go, oh, I took a car, let me put a 1 in. The problem with this approach is the documentation that's required. How does the user of your class know that 1 is a car, 2 is a plane, and 3 is a train? How do we tell them that? They'll have to read documentation, which is not easy. So now imagine a situation like this. I define an enumeration. So I go enum, and I'll call it transportation. And then I'll say that transportation has a car, a plane, and a train. And you could add more if you wanted, right? So now instead of using an integer here, let's use this custom enum as the data type. So now we have a variable of type transportation called transportation type. Now back in program, look what happens here. If I try to assign transportation, it gives me IntelliSense and says, oh, this is actually an enumeration of type transportation. And if I double click on that, you can see if I type in dot, it shows me all of the possible options that this can be. So now I don't even need documentation. This is self-documenting in its own. So if I say my transportation type was a car, I could just use car. If I say it was a train, I can just say train. And everything works. And on top of that, I don't even have to worry about the case where a user types in some random data because they can't even do that anymore. They have to use a transportation value. So that's the usefulness of an enumeration, situations like this. All right, so let's jump back to our slides and let's continue on looking at enumerations. Now, enumerations can also be printed and displayed. So here, notice how we have that enumeration defined as months, and we're creating a variable of type months, and we're saying that the month December is holding the actual enumeration month December. So if I wanted to print some information about this, notice how we're just using some basic placeholder technique here. If I say December.toString, that will print the value of the enumeration's like identifier. So in that case, it would print December. If I cast it, and we really haven't seen this syntax yet, but if I cast it to an integer by putting int in parentheses before the name of the variable, this means get me the integer representation of this. So in that case, it would say 12. So you can print both the string form and the integer form using the cast operator. Now I can also cast the other way. So in this example, you can see I created a variable of type months again, and I'm trying to assign it to the value 6. Well, we know 6 is June, but if I want to actually do that, I need to cast that integer to a months. So by saying months 6, this will now store the enumeration value for June inside this variable, and then I can reprint it out here. Now, I already kind of talked about this, of why enumerations are valuable, and we looked at a couple of things, right? You saw IntelliSense can help the user of the class or enumeration to figure out what exactly are the possible values, because it's only going to show you the valid values here, which can help the user because this is now self-documenting. All right, let's do another flash quiz. Question number 1. If you don't assign a numeric value to the first enumeration, what will the default value be? So the answer here is 0. Remember that when we didn't assign any values, the first, which was January, started at 0. Number 2, calling the toString method on an enumeration will print the numeric value. Is that true or false? And that is false. By calling toString, we get the string representation of the enumeration. Alright, so in this last section, we did a brief overview of what enumerations are and why they are somewhat useful to us. In the next class after this, we're going to look at the other half of a class. So far, we've seen creating fields inside of classes, and now we're going to start diving into creating methods inside of a class. So that brings us to the end of the recording for today. I want to say thank you for listening, and I'll see you in CSC 104.